Welcome back to Fun Facts Online. Today, we are stripping away the abstract layers of the internet to look at the physical engine underneath. We are diving deep into the practical reality of green coding and sustainable software engineering. If you have listened to our previous segments, you know that the digital world is responsible for a massive amount of real-world carbon emissions. But knowing the problem is the easy part. The hard part is fixing it. So how do we actually engineer a digital ecosystem that doesn't drain the planet? It starts with visibility. You cannot fix what you cannot measure. In the world of software, we have developed sophisticated ways to track bugs and crashes. But tracking energy is a newer frontier. Let's look at two specific tools that are changing the game. First, there is the Green Metrics tool, or GMT. This is not just a calculator. It is a holistic measurement engine. Imagine a wind tunnel for aerodynamic testing, but for software. The Green Metrics tool works by spinning up containers. These are isolated environments where the software lives, and then running a standardized user flow. It automates a user loading a page, scrolling down, and clicking a button. While this simulation runs, the tool measures the actual energy draw of the underlying hardware. It captures the wattage used by the CPU and memory during that specific scenario. The result is a precise green score for that usage flow. It bridges the gap between code and physics. Then we have a tool you might already know, Lighthouse. If you are a web developer, you use Lighthouse to check performance and SEO scores. But here is the secret. That performance score is actually a proxy for energy efficiency. There is a direct correlation here. High performance means the code executes quickly. It means the CPU spends less time crunching numbers. It means the radio antennas on your phone are active for shorter periods. Therefore, a high performance score on the web is almost always a high energy efficiency score. Speed, it turns out, is green. Now let's move from measurement to action. If you are a developer, or just someone interested in how digital products are built, there is a checklist of actionable best practices that can be implemented today. We can break this down into 3 pillars: Frontend, Backend, and DevOps. Let's start with the Frontend, the part of the software you see and touch. The first major shift is the default adoption of dark mode. This isn't just an aesthetic choice for night owls, it is a physics-based energy strategy. This applies specifically to OLED screens, which most modern smartphones use. On an old LCD screen, there is a backlight that is always on, regardless of what is on the screen. But on an OLED screen, each pixel is its own light source. To display black, the pixel simply turns off. It draws zero power. Therefore, dark pixels consume significantly less power than white pixels. By defaulting to dark mode, we are literally turning off millions of tiny lights across millions of devices. Next is lazy loading. This is a strategy of patience. When you open a web page, the browser usually tries to download everything at once. But why burn energy downloading a high-resolution video in the footer of a page if the user never scrolls down that far? Lazy loading tells the browser to wait. Do not load images or videos until the user scrolls to them. It saves data, it saves battery, and it saves the energy required to transmit those bytes across the network. The third front-end pillar is efficient image formats. We are used to JPEGs and PNGs, but they are aging technologies. Modern formats like AVIF or WebP offer superior compression. They look just as good, but the file sizes are significantly smaller. Smaller files mean less data moving through the cables and data centers of the internet, which directly reduces network energy consumption. Now, let's go deeper into the backend. This is where the heavy logic lives. The golden rule here is simple: cache aggressively. The greenest request is the one that never hits the server. Every time your phone asks a server for data, electricity is burned. If we can store that data locally on your device, or on a server closer to you, we avoid the energy cost of the round-trip computation. Caching is the art of doing the work once and reusing the result a million times. Then we have SQL Optimization. Databases are the memory of the internet. When an application asks a database a question, like finding a user profile, a poorly written query might scan the entire table, literally reading every single row to find a match. This burns massive amounts of CPU power. By using indexes, we create a roadmap that allows the database to jump straight to the answer. It is the difference between reading every book in a library to find a quote versus looking it up in the catalog. Indexes save the planet. The final backend point is a bit of digital housekeeping. Remove dead code. Software projects grow over time, and often features are abandoned, but the code remains. This dead code still requires testing. It is still compiled. It still takes up storage space. It is zombie code that requires maintenance energy for zero value. Deleting it is an act of sustainability. The third pillar is DevOps, the infrastructure that runs the code. There is a massive win here that is often overlooked: turning off dev environments. Development and staging servers are used for testing, usually during working hours. Yet many companies leave them running 24/7. Do your staging servers need to run on weekends? Probably not. By automating them to shut down at 7 p.m. on Friday and boot up at 8 a.m. on Monday, you instantly achieve a roughly 30% energy saving. It is like turning off the lights when you leave the office, but for servers. The other major infrastructure shift is the move to ARM architecture. For decades, servers ran on x86 processors, like those from Intel or AMD. But recently, chips based on ARM architecture, like AWS Graviton or Azure Ampere, have taken over. These chips, originally designed for mobile phones where battery life is king, provide significantly better performance per watt. Switching your cloud infrastructure to ARM is one of the most effective hardware changes you can make. So that is what we can do today. But what about tomorrow? The future of green software is being written right now, and it involves three fascinating areas: regulation, DNA, and quantum computing. First, regulation. The era of voluntary sustainability is ending. The European Union has introduced the Corporate Sustainability Reporting Directive, or CSRD. This forces companies to report on their Scope 3 emissions. Scope 3 includes the indirect emissions from the supply chain, including the software a company buys and uses. Soon, having green code will not be a nice-to-have feature. It will be a legal compliance requirement. Software vendors will have to prove their carbon footprint to sell their products. Second, we have a storage crisis. Humanity generates more data than we can store on silicon. We are running out of physical space and energy to keep hard drives spinning. Research is currently underway into storing data in synthetic DNA. Nature has already solved the storage problem. DNA is incredibly dense and stable. Once data is written into synthetic DNA, it requires absolutely no energy to preserve. It could sit in a vial for 1,000 years without a single watt of electricity. This could solve the energy crisis of cold storage, archiving data that we need to keep but rarely look at. Finally, there is quantum computing. This is a bit of a paradox. Current experimental quantum computers are incredibly energy hungry. They require supercooling to near absolute zero. However, they promise to solve optimization problems that traditional computers simply cannot touch. Imagine optimizing the entire logistics grid of a global shipping company, or managing a national energy grid in real time. A quantum computer could solve these problems in seconds, where a supercomputer would take years. The hope is that the energy saved by these optimizations will far outweigh the energy consumed by the quantum computer itself, offering a net positive energy payoff. To conclude, I want to leave you with this thought. Green coding is, at its core, about quality. It forces us to strip away the bloat, the inefficiency, and the waste that has accumulated in our digital ecosystem over the last few decades. It aligns the goals of business, which wants cost reduction, with the goals of engineering, which wants performance, and the goals of humanity, which needs sustainability. As software engineers, and as users, we are the architects of this digital world. We have a choice. We can build a world that drains the planet, or we can engineer a future where technology and ecology thrive together. The code written today determines the climate of tomorrow, so write responsibly. Thanks for listening to G Fun Facts Online.